discuss the other cases, right? So here, case number 2. Look at once again that case number 2. What is case number 2 here? Simply we need a curved surface, right? That interface which is separating the both medias. One is air and the other is water. Here curved surface is separating. Okay, we have that identifying the pole. That means what? Simply it is the midpoint on the curvature. That point, red point indicated, that is nothing but your pole. You can call it as pole. So representing with the letter P here. Then identifying its center. It's a center and denoted by the letter C here. Then the line joining the pole and the center of curvature is called as principal axis. Then we have all these, right? I have all these. Incident a light ray, that which is parallel to the principal axis, right? Here, see, denser medium and rarer medium separately showing here, right? Then that look at in which medium that ray is parallel to the principal axis. It is in the denser medium and it meets the convex surface. It meets the convex surface. It is parallel to the principal axis and it is in the medium called denser. So what happens if a parallel light ray incident on the convex surface? It enters into the rarer medium. Okay. What happens if it changes a medium? It bends. So we required normal to the point of incidence. So I got it. Then here observe the angle. It is somewhat. Then in the rarer medium, it is going to be increase or decrease. It increases. That means it bends away from the normal. So this is the behavior of a light ray. When if a parallel light ray, that means parallel to the principal axis, incident on a convex surface and entering into the rarer medium, it bends away from the normal. This is your case 2. Next, we have next case. So this is given in your figure number 4b. Look at that in your textbook. Then we have another case, that is here case number 3. That is what here, simply look at. Interface is separating the both media, right? Now the concave surface is in contact with the denser medium and convex surface is in contact with the rarer medium. Look at that. Then identify its pole, name it with the letter P. Then next here see that which is rarer medium, which is denser medium is given on the screen. Rarer medium is air and the denser medium is water. Then that point on the curvature is called as pole. Identify its center, name it as C. Then join them. That line is called as here principal axis. Let me consider the case here that ray is parallel to the principal axis. Ray is parallel to the principal axis. Then here it is going to meet the concave surface, right? It is going to meet the concave surface, but it is in the denser medium, passing from denser to rarer medium. What happens here? So here also we are depending on the normal. Construct the normal from the center of that curvature to the point of incidence. So we got the normal here. Then what happens to the light ray when it enter into the rarer medium? It bends away from the normal. So it is moving away from the normal. Then observe, in the previous case it also moved away from the normal, but it never meet the principal axis. But in this case exactly it is going to meet the principal axis in the rarer medium, right? So it is going to meet the principal axis. So here look at, the ray is parallel to the principal axis and it is passing from denser to the rarer medium. On refraction it meets the principal axis. That is generalization. Case number 4. See here that what is your case number 4. So same diagram I am using. as we discussed in the case number 3. So here convex surface is in contact with the denser medium and concave surface now in contact with the rarer medium. But in the previous case, concave surface in contact with the denser medium, convex surface in contact with the rarer medium. Just made opposite now, right? Then identify that a curved surface, automatically it's a pole. Then identify it with the letter P. Next, center of curvature. Then join them with your straight line, that is called as principal axis. Name it. Then identify the rarer medium, denser medium. After that, consider a ray parallel to the principal axis. Now construct the parallel ray that is in the rarer medium. It meets the concave surface, right? Which surface it is going to meet? It is concave surface. Now what happens? So before going that, we need normal here. In the denser medium, light ray bends towards the normal. So like this, here your light ray passes in the denser medium. What is the similarity between these figures A, B, C, D? 4A, B, C, D. Is there any difference or similarity? One of the similarity in all the cases is we consider only the parallel ray to the principal axis. Difference is, okay, I will give you, see, parallel ray meets the convex surface. I am not saying about the medium. Parallel ray meets the convex surface. See, it is given in the 4th A figure, S, and it is also given in the 4th B. What is the difference? In both cases, the light ray incident on the convex surface only. But what is the difference? In one case, it meets the principal axis. In the other case, it is moving away from the principal axis. Why it is happened? It is because of medium. In 4th A case, that parallel ray in the rarer medium. In 4th B, that parallel ray in the denser medium. Right? Look at that 4C and 4D also. In both cases, it that ray incident on a concave surface, but behavior is different, quite opposite, converging, diverging, like that, towards the normal, sorry, towards the principal axis and away from the principal axis. Both are there, right? So observe carefully. Is there any similarity between 4th A and 4th D? Sorry, 4th A and 4th C. Right. But what about that point of incidence, that surface nature? Quite opposite. Is it? One is concave, one is convex. Do you see that? Likewise, here mediums also opposite. See, 4th A from the rarer to denser. In 4th C from denser to the rarer. So likewise, just you have to identify them. So this is your 4th figure D. Then what we have, see here we have discussing about this. What I said, just to understand about refraction, I told you many times, just take one transparent glass and fill it with water and observe by just keeping one pen or pencil. Did you see? See here, this is the interface where the light changing its medium. Here it is changing in the medium. Yes or no? Here that pencil, one of the part lying in the air and the other is in water, right? So what happened here? Bending. This phenomenon only called refraction. Refraction means nothing, just bending of a light ray. How do you explain? Just take it this simple example. You are able to explain it about refraction. So look at here. One more I am taking. What is? It's a
Ball.
lemon. Okay, you can imagine as ball also, no problem. Myself, it is giving us lemon. What happened? What you are observing? Are they both different lemons or only one piece? That means one lemon.
One lemon.
But I am looking as two. How it is possible? Here the size also different. Both are having the different sizes. How the size is magnified or enlarged. See,
What?
it is big in size comparing with the outside one, smaller in size, but both are given by the same lemon. Suppose if there is no water in the glass, do you see any change in the size of lemon? Or are you able to see these are two parts of lemon? No. Only it is because of what? Presence of water. Is it looks smaller or larger in size than compared with its original? So how do you feel? It's large. Why it is? Any idea? Look at here.
Refraction.
Look at here. What do you see? Lemons in the glass of water. How you are feeling? It is enlarged. It is enlarged. Why the lemon in a glass of water appears bigger than its actual size? Are you feeling at least? We don't know the reason. Okay, we'll discuss about the reason. Are you feeling at least it is bigger in size? So actually what you are viewing, the lemon or its image? Its image you are viewing. How its image is possible, sir? Actually there is a lemon and glass, totally they are transparent. In that case also I am able to see that image. Yes, because here this phenomena is there. What is that?
Refraction.
Refraction of light. Due to this you are able to see that image of the lemon and enlarged one. Do you know the reason? Are you able to explain that phenomenon by the ray diagram? Yes, now we are able to. What it is?
Glass.
Yes.
Glass.
Empty glass or water glass? Having water?
Sir, empty glass.
Yes. Let me drop a lemon in that. So myself, I fixed here to see that lemon. Right? So view from the side of the glass. Right? Then drop the lemon inside the glass. Then what do you see here? Just
Normal.
Normal.
with the light from the object. So I consider only two rays. What they are? They are started from the top of the object and the bottom of the object. When they hit this glass surface here, entered into the glass. As we discussed in activity 1, that refraction takes place inside the glass and it bends. Okay. So from there you are going to receive the light onto your eyeball. Then it forms the image. You can view that. But here simply if the water added into the empty glass, water is filled now, what do you see here? So when the water added into the glass, what happens? That glass and water refractive indices together we will take. So it is acting like a single media now, right? Then what do you feel yourself simply when the glass is filled with water and the lemon is dropped in that? See here, what your eye can imagine, that light rays are coming from that point, what I am showing you with the black colored one. Are you able to see?
Yes, sir.
You can imagine itself that light rays are coming straightly from upper, right? So your eye can imagine that lemon is in this size. See. So actually, is it happening?
Yes.
Eye is imagining due to what? Refraction of light. Right? So that is the image. Now what you are viewing? Image. Previously what the size you observed? Smaller. That is the original object. image formation and derivation of a curved surface formula. Right? So here first we need to explain the formation of image. Let me know what you know. Here I am asking about your previous knowledge here. In a reflection, you drawn ray diagrams. Is it in your 8th class?
Yes.
How many rays are required to explain the formation of image from the same point?
2.
Minimum 2 rays,
2.
which are started from the same point. It is top of the object, right? So you are going to consider. Likewise, here to get or to explain about the formation of image in refraction also, we required 2 rays minimum. How many? 2 rays. From where they have to start? From the same point. Okay, na? That is top of the object. Suppose this is the object. Which is top here? This one is top. From there, at least 2 rays you have to construct to meet the curved surface. Then what happens? Already we discussed the behavior of light ray in that changing medium by instant on a convex surface or concave surface, right? So now we are explaining the formation of image, right, with the refraction. So what I have on the screen, it is what? Curved surface.
Face.
So left side, what you are viewing the surface is bulged one or curved inwards? From the left. This is left. This is right. Now I am asking you about left
So
side.
not well good.
It is bulged. Called as which surface? Concave or convex? No, bulged out exist. X convex. Am I clear? That logic?
Yes, sir.
Right? Keep that in your mind. Logic. Okay, now you never forget surface. Okay, na? Right. So already I told you depth, cave, inside. Okay, na? Right. Next, what you need on the curvature?
Pole.
Writing the mediums first. This shaded region is what? It is denser medium. Before the convex surface is rarer medium. Right? Do they have same refractive indices?
No.
No. So here I am taking the refractive index of the rarer medium as N1 and the refractive index of denser medium as N2. Here we know N1 is not equal to N2. It may be less than or greater than, we will decide. So rarer medium having refractive index less than the denser medium. So who is with a greater refractive index? It is denser or rarer? Denser. Right. So here now I identified a point on the curvature. This point is what? It is called as pole, denoted by the letter P. So for every curved surface, it has a center from which it made a part called as center of curvature, denoted with the letter C.
C.
And next I am joining the 2 points with a line called, let me select an object, right, on the principal axis before the convex surface in the rarer medium. That means in the rarer medium. So always we are going to place the object on the principal axis or above the principal axis. Clear? Depending on the size. When you are using on the principal axis, it is having point size. Its size is point size. So I selected point size object in front of the convex surface, which is in rarer medium. Is it clear? So this is my object, indicating with the letter O. O reads for object and at a point O. Is it having any height? No height. Its size is just point size. So it is on the principal axis. Then choose 2 rays. Right? 2 rays from the same point of the object. So it is already point object from the same point, red color spot at O, that I will choose to select 2 rays. No angle with the principal axis. That means along with the principal axis. Is there any deviation if a ray passing along the principal axis or passing through the pole? No deviation. So it goes straight without any deviation. So one of the rays selected along the principal axis. So I used one of the ray undeviate, remains undeviate, no refraction. Okay, next I will select one more ray from the same point O, right, to meet the convex surface at a point. Look at here, I drawn a ray to meet the convex surface, right? That means that ray is making something angle with the principal axis, right? So that angle I have shown, are you able to see? That angle I will take it as something alpha, I don't know, I am giving, or that value given with a letter called alpha, right? Then next, here where that light ray going to meet the convex surface, there I am identifying a point and denoting with a letter A. So where that light ray meets the convex surface, or at which point it is incident, at point A. Then what happens, we know that light passes through that because it is a transparent, then enters into the denser medium. What happens if light ray enters into the denser medium? It bends towards the normal or away from the normal?
What's the normal?
In the rarer medium, away from the normal. In the denser medium, towards the normal, right? So to identify that one, I need this one. What is normal? So here, is it making any angle or not with the normal, that light ray?
Yes.
What that angle is called as? The incident ray made something angle with the normal called as angle of
incidence.
incidence. So let me take that angle of incidence here as theta 1. Right? Up to here we are given as angle of incidence I. Now I am imagining that angle of incidence as theta 1. Okay. Then what happens when the light ray enters into the denser medium? We know that it bends towards the normal. Then extend that light ray where it meets the principal axis. There you have to stop. Is it going to meet the principal axis or not?
Yes.
Yes.
Sir.
Identify a point there. I got a point. So what this point actually? How you got that point actually? It is a converging point of which light rays? Refracted light rays, right? Which are started from the same point of the object. So that refracted rays converging at a point, they can form the image of the point O. So where I will get the image? At this point. So denoting that point as I. O stands for object, I stands for image. What is the size of image here? Is it having any height above the principal axis or below the principal axis? No height. So what is the size of image? Point size. Point of a object, point size image. Right? So first, before going that, what is angle of refraction here? We don't know. Just assuming that angle of refraction is theta 2 here. What is theta 1? Angle of incidence. What is theta 2? Angle of
Refraction.
Then let me take that angle made by the normal with the principal axis is something beta. Then the angle made by the refracted light ray above the principal axis, not on the principal axis, there is no angle made by it, undeviate ray. So that blue color ray, that which refracted with the angle theta 2 makes something angle with the principal axis here. That angle I am taking as gamma. Right? So this is, then I need here one normal from the point A onto the principal axis. So I will draw a line that which meets the principal axis and make angle 90 degrees. Look at here, that green color line onto the principal axis. So where it is going to meet, that point I will take it as something N. So AN is what? Normal to the principal axis. Right? That where I have drawn at the point of instance. Okay, so this is about the diagram which is given in your textbook. Is it clear explanation?
Yes.
How to understand the diagram? If you think, just you will get how to understand the given diagram. I am given complete explanation for that each and every point. Is it clear, everyone?
Yes, sir.
Yes. What it is actually, you got one line between O and P. It is what? Measurement, length. So from the pole to the object, what we will measure? The distance. object distance. It is called as object distance and denoted by the letter U.
U.
U measures object distance between whom? Pole to the object. Okay, na? Pole to the object. That distance is called object distance.
Object distance.
Then one more look at here. What it is? The length or the distance between the P and C. What is C actually? Center of curvature.
Curvature.
Center of curvature to the boundary. That distance is called radius of curvature, R. Look at here. One more. I am showing you. Image. That is what? Image distance. Pole to the object is object distance. Pole to the center is radius of curvature.
Radius.
Pole to the image is image distance.
Image distance.
Denoted by the letter V. Right? U is object distance, V is image distance, R is the radius of curvature. Is it clear?
Yes, sir.
So let me minimize this one. So look at, I have that minimized image. So all the points which we discussed available to use them. Is it? Look at here. What is U? It is
Object distance.
It is between P and O. PO is called object distance.
Object distance.
Then EC is called radius of curvature.
Radius of curvature.
Given as R. Then image distance given as PI denoted with the letter V. Right? Then look at my question here. What is? Are you able to establish a relation between the quantities mentioned above? Are you able to establish a relation between them? U, V and R. So that is actually we are calling ice curved surface formula. Right? What we are calling is curved surface formula. Actually we need to mention two more quantities here. What they are? Can you guess? They are refractive indices. What they are? N1 and N2. Refractive index of the rarer medium and refractive index of the denser medium. Okay, so what I require here to establish a relation between the quantities here U or V, I need to observe the triangles with exterior angles. So which are having the exterior angles? What is theta 1? Is it exterior or not?
Exterior.
To which triangle it is? For the triangle ACO, right? ACO. Right. Here exterior equal to what? Sum of the two interior angles. Are you able to see this one diagram? See here,
Yes, sir.
this triangle is, right? That is your triangle ACO. There, here this one is exterior. Okay, now if you extend AC, you will get exterior angle here. Right? Am I clear? So theta 1 is what? Exterior. What are the interiors? Alpha and beta. So exterior angle equal to sum of the two opposite interior angles. So according to that mathematical principle, I am writing theta 1 equal to alpha plus beta. Is it clear? So let me find one more triangle with exterior angle. Is it available? Which has exterior angle here? Consider only triangles. What they are? See here, alpha is there, okay. It is not exterior. Theta 1 already completed. Theta 2 is exterior to any triangle? No. Theta 1 already completed. It is not exterior, right? What are remaining? Gamma and beta. Gamma is what? Interior angle. It is also not. Then what is remaining here? Beta. So beta is exterior. For which triangle? It is triangle. If you take ACN, it becomes interior. ACO becomes interior. Yes or no?
Sir, ACI.
ACI is correct. Right? So what is the relation you are able to give between interior and exterior? So exterior angle beta equal to sum of the two interiors. Theta 2 plus gamma. I have written. Right? Then transpose it to find out an angle of refraction theta 2. So what I am able to write? it is beta minus gamma. So from the relation beta equal to theta 2 plus gamma, I am writing theta 2 is equals to beta minus gamma. Am I clear? Yes. What is theta 1? It is angle of incidence. What is theta 1? Angle of incidence. What is theta 2?
Angle of refraction.
So do I have that values or not? Theta 1 equal to, I have alpha plus beta. Theta 2 equal to beta minus gamma. I got some values, right? So just try to give a relation between this angle of incidence and angle of refraction. Which relation will give you that relation? Which principle? It is Snell's law, right? So the relation between incident and refracted angle established by a law called Snell's law. What is Snell's law? It is N1 sine I is equals to
N2 sin R.
sine
Sin R.
R.
I here theta 1. What is R here? Theta. Because according to our situation. Yes?
Yes.
Okay, confusion here. Just using that only I am writing the relation here. So what I have written? N1 sin theta 1 equal to N2 sin theta 2. Is it clear?
Yes.
Right. So drop that values theta 1 and theta 2 in the relation. So what you will write? N1 sin alpha plus
beta
equals to N2 sin beta
minus gamma.
gamma. Right? So substitute theta 1 and theta 2 values in Snell's law. You will write N1 sin alpha plus beta equal to N2 sin beta minus